Hey guys, welcome back to Maths Recovery with Rebecca. So today we are going to start looking at grade 11 trigonometry. So I'm going to start with the very basic, just reduction angles today. And we are just going to look at single reduction angles. So we're not going to look at sums with division and multiplication where you've got to reduce multiple things at the same time. We're just going to look at 4 basic reductions. And then in the next video, we will go up a notch and do some division, some adding, maybe even put in some factorizing in there. But anyway, let's hold on to our socks and let's start. Might be a good idea for you to get out a piece of paper, write this down, because this Cartesian plane will be the most important Cartesian plane that you come across in your whole schooling career. Okay, so let me go and choose a different color here because everything seems to be in red. And let me explain to you what is happening. So in our Cartesian plane, we have our ratio. So SOHCAHTOA, that's something that you learned in grade 10. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. That is information that you know. What you also learned in grade 10 is the quadrants, all, sine, tan, cos. So these quadrants represent where these ratios are positive. So they're all positive in the first quadrant. Only sine is positive in the second quadrant. Tan is positive in the third quadrant. And in the fourth quadrant, only cos is positive. So I've got this little diagram here on the side. So this is classified as the cast diagram. So the reason why I have this little man fishing over here, because when he casts, that line goes right back, starting in the fourth quadrant. That's C-A-S-T. And that's how you can remember where they belong. Okay, so in grade 11, you start something called reduction. So basically, what we're going to do is we're going to take obtuse angles and we are going to reduce them. Yes, it's in the name. We're going to reduce them to an acute angle. But before we even start that, we need to have information. Okay, so the first thing is we're going to use 0, 360, and 180 for reduction. So the 90 and the 270, that is cofunctions. So I will look at that in a video further on. Those are also forms of reduction, but they are forms of reduction when the ratio changes. For now, you need to only focus on 0, 360, and 180 for normal reduction. So in quadrant 1, we have just the theta, which is the goal. In quadrant 2, we have 180 minus theta. Remember, we're working off these two. So either it says, because this one will be just theta. And then we're working in these two quadrants, which would get the 180 minus theta, 180 plus theta, and in this fourth quadrant will be 360 minus theta. All of these short sum or difference little expressions over here create acute angle, which you'll see now in the next slide. Okay, so what is reduction? It's a process of making a trigonometric ratio of a non-acute angle into an acute angle. So the example that I've shown there is sine 210 is equal to negative sine 30. Now, I'm going to show you how I got that answer of negative sine 30. Okay, so I wanted to just draw it for you roughly, very roughly in the Cartesian plane of where 210 is. So it'll be between 180 and 270. I just roughly thought like 190, 200, 210. It's probably really off, but like I said, it's a rough sketch. So starting at 0, that's 210. Let's look here. If I had to go and draw the same angle, just a reflection, you see there, into quadrant 1, that's exactly what it would look like. And let's look at that. So the goal is to make an acute angle. Well, there it is there. Those two angles are exactly the same. And we'll look more into this when we're doing, tan theta is equal to gradient. In analytical geometry, you'll see a lot of things where we, where we reflect over axes. But this is the beginning of it. And that is the main reason as to why we use the 180 plus theta. If we use 270, it's not going to give us this 30-degree angle, the reflection over into the first quadrant. Okay, so what does this all mean? You see I've got that 2 over there to show you in this quadrant tan is positive. Okay, so how do I even get this negative 30? Negative sine 30. So there's a few questions that you've got to ask yourself. Which quadrant does 210 lie in? So we already established that that lies in quadrant 3. Next question, whose quad is this? And what do we know about sine in this quad? Well, this is tan's quadrant, and we know that sine is negative. And that's you see that? That is why that has changed to negative. See that? Negative. And the last question is, what is the reduction formula in this quad? Well, it's 180 plus theta, and you ask yourself 180 plus what? And that what has to be acute. If it's not acute, you're in the wrong quadrant. Okay, 180 plus what is equal to 210, and it came out to 30. So that's how you do it. Sine 210, well, sine is negative in that quadrant, so it's a negative. Using the reduction formula that's given in that quadrant, 180 plus theta, we ask ourselves 180 plus what is 210? Well, it's 30. Okay, hopefully you understand, you've written all your notes, let's move on. Okay, so it was what? Quadrant. Which quadrant? Then it was, what do we know about sine? What is the sine? And then the last one was reduction. So quad, sine, reduce. QSR. You can use whatever you want, but that's what came to mind. Okay, let's reduce the following. You can pause it, do it yourself, see how it goes, but I'm going to start now. Okay, so I've drawn this thing on the side here, just so I've got my reductions, I've got all my ratios and where they're positive, where they're negative, and all that information. Okay, so let's look. So we're going to look at the quad. So where is 200? So I'm going to do this one in blue. 200 is roughly in this quadrant somewhere, right? So what do I know? I've got the quadrant. Great. What do I know about the sine of cos in that quadrant? Well, that's tan's quadrant. So cos is negative. And then I do the reduction. 180 plus what is 200? Well, 20. So this becomes cos 20. Done. Next one. Where is 130? 130, let's do this one in a different color. Let's do it in red. So 130 falls in this quadrant. What do I know about sine in this quadrant? Sine is positive. There I've got my sine. And the reduction is 180 minus what? Well, it's going to be 180 minus 50. So this becomes sine 50. Let's look at the last one. 320. Okay, let's do this one in green. Yeah, 320. 320 is in quadrant 4. It falls between 270 and 360. Well, what is tan's sine in this? Well, only cos is positive here. So this is going to be negative. So we've got the sine. Now we're going to reduce. Well, the formula is 360 minus. 360 minus what is 320? 40. So tan 40. Great. So they've all been reduced down to an acute angle, and those are my answers. Great. Thank you for watching. Hopefully you understand. In the next video, we're going to be looking at a lot all in one. Please remember, when you're doing this in a test, there's normally a mark per reduction. So if you've got 5 that you need to reduce, that's already 5 marks for the reduction. And then anything else that you have to do, getting common denominators or doing the keep change flip with the division fractions. All of that is worth extra marks. So some of these questions, which we'll be doing in the next video, can be worth about 5 to 7 marks. So it's very important that you understand how to do the basics of reduction. Anyway, have a good day. Please like and subscribe and share my video with your friends that are also struggling with this. And yeah, have a good one.